Hello everyone, welcome back to the next session of simple equations. Before starting next session, I'm going to give you the previous answers for the given worksheet. The first question from the worksheet is find the rule which gives the number of matchsticks required to make the following pattern. Use of a variable to write the rule. See the first question. In the first picture we have 5 matchsticks. In the second picture we have 9 matchsticks. In the third one we have 13 matchsticks. To make the rule I have taken variable as n, so the answer is 4n plus 1. If you want to take another letter as the variable, you can, it's your wish. So here I will take n. So second one, in the first picture we have 6 matchsticks, in the second picture we have 11 matchsticks, and in the third picture we have 16 matchsticks. So the rule is 5n plus 1. If n equal to 1, 5 ones are 5 plus 1, 6. If n equal to 2, 5 2s are 10 plus 1, 11. If 5 3s are n equal to 3, 5 3s are 15 plus 1, 16. Next, for the third one, same as it is second one. In the first picture we have 6 matchsticks, in the second picture we have 11 matchsticks, in the third picture we have 16 matchsticks. So the rule is same, 5n plus 1. Coming to the fourth one, in the first picture we have 8, in the second picture we have 16 matchsticks, in the third picture we have 24 matchsticks. So the rule is 8n. If n equal to 1, n 8 ones are 8. If n equal to 2, 8 2s are 16. If n equal to 3, 8 3s are 24. Okay, next, second question. Fill in the blanks. In each bowl we have x marbles. X marbles, first we have 4 bowls. If we add 4 bowls of marbles, what will be the value of the marbles? So we have 4 balls, so 4 into, in each ball we have x marbles, so 4 into x marbles, 4x is the answer. Next, a line segment is divided into 7 equal parts. Okay, we need to divide the given line segment into 7 equal parts. So what is the length of the line segment, sir? X by x meters. So we need to divide it into 7 parts. So it will become x by 7. Each part will be x by 7. Next, fourth one. Radhika is 3 years older than her sister Mallika. Find an expression for Radhika's age in terms of Mallika's age. So if Mallika's age is x years, then obviously Radhika's age is x plus 3 years, because Radhika is 3 years older than Mallika. Mallika's age is x years, then Radhika's age will become x plus 3 years. Next, fifth one. Deepika had x number of chocolate bars. She distributed 5 of them among her friends. How many chocolate bars are left with her? So previously Deepika has x number of chocolate bars. After distributing 5 chocolates to her friends, what will be the remaining chocolates with her? So for that we need to subtract 5 from total number of chocolates, that is x minus 5. Next, sixth one. Vikas purchased 3 pens each for x rupees. If he were to give a 100 rupee note to the shopkeeper, then find the amount he will get it back. So he purchased 3 pens, so each cost is x rupees, total cost is 3x. This is the cost of pens, but he given 100 rupees to shopkeeper. what is the change he will get back? So for that, 100 minus 3x. If we do 100 minus 3x, that amount he will get back. Next, seventh one. The number of stamps with Tanai are 1 less than the thrice the number of stamps with that Vihan has. So find a rule to determine the number of stamps with Tanai. First of all, if Vihan have X stamps, Vihan has X stamps. The number of stamps with Tanai equal to thrice means 3 times. So 3x minus 1. Tanai has 1 less than thrice the number of stamps that Vihan has. So Vihan has X stamps. Tanai has thrice 3x minus 1. Next, eighth one. Students of a class are made to stand in X rows, each row having 11 students. The last row has only 7 students. Find the rule to determine the number of students in a class. So, students of a class made to stand in X rows, each row has 11 students. But here in the last row only 7 students were there. Okay, so the rule is 11x minus 4, because in the last row we have only 7 students, not 11. Okay, next, ninth one. X pens are packed in each of the 10 boxes and 3 pens were left over. Find a rule to determine the total number of pens. X pens are packed in each of 10 boxes. So total 10 boxes. In each box we have 10 pens. So 10x plus 3 pens are left over. 10x plus 3 is the total number of pens. The length of a rectangle is x units. Its breadth is 6 units less than its length. Find a rule to determine its area. So rectangle area, we know that length into breadth. So the length is x units. X into breadth is 6 units less than the length. X minus 6. X into x minus 6. That is x into x minus 6 square units. So that's all. The answers will completed. Check your answers and do your worksheets regularly. So here is our next class. In the previous class, what we discussed about constant, variable and literal, patterns and algebraic expression, equation. Here our next topic is linear equation. What did it mean by an equation in which the highest power of the variable is 1 is called a linear equation. The highest power of the variable of an equation is called linear equation. Okay, sorry, once again, an equation in which the highest power of the variable is 1 is called linear equation. Example, 3x equal to 21. In that, x to the power of 1. The power of the equation is 1. So the highest power also, here it is 1. That's why 3x equal to 21 is a linear equation. Actually, what did it mean by power, sir? We don't know that. Okay. What is mean by power? So the power is nothing but a variable is multiplied by itself number of times. Okay, the power is nothing but the variable is multiplied by itself number of times. Example, x is squared, so that equal to x is multiplied by x 2 times, x into x. So the power of x is nothing but 1. So x into x, 1 1. Here bases are equal now, we have to add the powers. X is the base, 1 is the power. So bases are equal. When bases are equal, we have to add its powers. 1 plus 1, 2. So x into x is nothing but x square. So the power is 2. Next example, x power 5. X is multiplied by x itself 5 times. X into x into x into x. So 5 times. So power of x is 1. 1 plus 1 plus 1 plus 1 plus 1. Total 5 times. So 1 plus 1 plus 1 plus 1 plus 1, 5. So power is 5. X power 5, power is 5. Okay. In this way we are going to calculate the power of an variable. Power of the variable. So here we need to know one more thing, degree of an equation. How you are going to calculate the degree of an equation. In the previous linear equation definition, we come across the highest power of the variable. Here also in the degree of an equation, the highest power of the variable is called the degree of an equation. Okay, the highest power of the variable is called degree of an equation. Here the example equation is x square plus 2x plus 1 equal to 0. Okay, so here highest power of the variable is 2, because x into x square, the power is 2. 2 into x power is 1. So 1 is nothing but constant. Always the constant power is 0. Okay, so that's why highest power is 2. So degree is also 2. Actually, how to calculate the degree of an equation? To understand in better way how to calculate the degree of an equation, let's take x square plus 2x plus 1 equal to 0 as a equation. So the power of x square equal to x is x into x. So x to the power of 1 into x to the power of 1. What we discussed earlier, if bases are equal, the power should be added. Bases are equal, powers should be added. So x to the power of 1 plus 1, that is x square. The power of x square is nothing but 2. The power of x power 1 only. There is no another variable there. So that's why x power 1. The power of x is 1. The power of constant is always 0. Okay, because we write x as x to the power of 0 into 1. So the value is 1 only. That's why x to the power of 0. Power is 0. So the highest power is, in the given equation, the highest power is 2. So it will become the degree of the given equation. So what is the degree of the given equation? X square plus 2x plus 1 equal to 0 is 2. Okay, that's all for today. Tomorrow we are going to learn about linear equation in one variable. Okay, tomorrow we are going to learn linear equations in one variable, and what is left hand side and what is right hand side, and also the solution for the linear equations in many methods. Thank you.